Hello, everyone. So this lesson is going to be on using a hierarchy to classify and understand your quadrilaterals. Excuse me. So if you look at your success criteria, which was on that very first part of the module, which was on the overview, you'll see that you're supposed to explain that a category of quadrilaterals also can belong to a subcategory. And then you're supposed to be able to classify quadrilaterals in a hierarchy based on its properties. So that word hierarchy, you may not be familiar with, but a hierarchy is just a way to organize something or an object into categories based on its attributes or properties. So to help y'all make a connection to what a hierarchy could be, I've done one with candy. I know y'all like candy. I'm sure you miss me giving some to you when you do well. But here is what I've come up with candy. Now, one thing, I know this looks a little crazy, but one thing when you look at a hierarchy, it can be in many different ways. This is kind of set up in a way that you can look from top to bottom or from bottom to top. But when you look at a hierarchy that's set up this way, at the top is the more general category, and then as you go down, it gets more specific. So for instance, at the top I have candy. The next part of the hierarchy breaks it into categories: chocolate, fruity, or sour candy. And then from the chocolate, I only used a couple, so that way that's all I had on my screen. I go into Hershey and Reese's. And then you even see here's where those subcategories come in. For Hershey, we have the ones with the almonds, we have the dark chocolate Hershey's, we have the cookies and cream Hershey's. They're all different types of Hershey's chocolate. And same for Reese's. There's just the regular Reese's, there's the crunch, there's the white chocolate. Same for fruity. We have Starburst, we have Skittles. Again, more fruity candy, but I'm just putting a couple on here. And then even for Skittles, we have those rainbow, we have those funky color Skittles, we have those sour Skittles. And then in the sour category, we have like Warheads, we have Sour Patch Kids, and I even included that sour Skittle there. So what you're kind of seeing is a hierarchy kind of breaks it down from a general category into more specific. But what else a hierarchy does, lets you describe things in the hierarchy using statements like always, sometimes, or never. So if you kind of look down here on my screen, I have all blank are blank. And when you look at a hierarchy, those items that are more towards the bottom fit into every other category that it's connected to up to the top. So for instance, this cookies and cream Hershey, I could say all cookies and cream Hershey bars are chocolate because that's true. The cookies and cream is connected to the Hershey, which is connected to the chocolate. I could also say that all cookies and cream Hershey bars are candy. Again, that's true. It's connected all the way to the top. So what you'll find is in a hierarchy, what's on the bottom, what's more specific, fits into every other category that's above it. So one example I could write here, which is what I said was all cookies and cream Hershey's are chocolate. Okay. Now this word, and then you could do ones that talk about some. Now I could not say all chocolate is cookies and cream because not every single piece of chocolate when I go to the store is going to be cookies and cream. Some chocolate will be cookies and cream. So what you're going to notice when you go top down is it's not always true. It can be sometimes true or never true. So I could put here some chocolate I'm going to change that is, I'm going to do C and C for cookies and cream, is cookies and cream. I could also say some chocolate is Reese's, some chocolate will be white chocolate, but again, when you're going top down, those top categories don't always fit into the bottom categories, but the bottom categories will always fit in the top categories. And then this last part talks about maybe something that will never work. So if you look at my hierarchy, these chocolate parts will never be associated or connected to this sour part. I have never had chocolate that has been sour. If you have, please educate me on what that was. So we also want to make statements of things that aren't related, because that's important. When we notice they're not related, it helps us understand how to eliminate those answer choices that don't make sense, or helps us see who it is related to and why that's important. So a statement I can make here is, I'll put white chocolate Reese's are never sour. And I can show you that on this hierarchy right here. White chocolate Reese's has no connection to the sour. There is no line that leads over here. And obviously common sense, I know that a white chocolate Reese's is not sour. It is sweet and yummy, okay? So basically, again, a hierarchy helps you organize things into categories, and then helps you make statements about their attributes or properties using that always, sometimes, or never. So now that you've seen a hierarchy with candy, I'm going to now connect that to a hierarchy that you're going to need to do according to your success criteria with quadrilaterals, okay? There's 3 different ways that a hierarchy could look for you. It could look very similar to my candy one, where there's a category at the top and then it filters down below. A hierarchy could look like a Venn diagram, where the most general category is at the top, and then inside each part, just like a Venn diagram, it includes the other categories, so it gets more specific. Or it could look like a flow chart. I know y'all have seen this in science. Starting at the left is the most general, and then as you go to the right, it includes those topics. It gets more specific. So I'm going to go through each of these hierarchies, and then we're going to practice some of those sometimes, never, or always statements. So if you look at this one, the most general topic is quadrilaterals. That's your main focus in 5th grade geometry. A quadrilateral is a 4-sided and 4-angle polygon. So again, there's many different quadrilaterals. We could say there's a trapezoid, there's a parallelogram, and there's a kite. There's even quadrilaterals that don't really have a name. But those are the 3 categories we focus on. And then based on the definitions of trapezoid, parallelogram, and kite, I could go into further subcategories, okay? The one that has the most that goes underneath of it is parallelogram, because that has 2 sets of parallel lines. There's lots of quadrilaterals that have that, which is why it can also be called a parallelogram. So, that's one thing about a hierarchy, is the hierarchy also shows you multiple names that a polygon or quadrilateral can be called. So underneath the parallelogram, we have a rhombus and a rectangle. Both of those have 2 sets of parallel lines. And then you'll notice underneath is that square. A square has 4 right angles and congruent sides, which is why it's connected to the rectangle. 4 right angles, and it's connected to the rhombus because of the 4 equal sides. Again, this is very similar to my candy one. What's on the bottom can fit into the categories it's connected to as you go up. So technically, a square is a rectangle, it's a rhombus, it's a parallelogram, and it's a quadrilateral. It can be named all 4 of those names because its properties have everything those have. Okay. If you look at this kite and this trapezoid, there's not a lot that it can be called. It can be called a trapezoid or a quadrilateral. It can be called a kite or a quadrilateral. There's not too many lines connecting that, and that's based on its attributes or its properties. So if you look at here, it says when you look at the shapes at the bottom, then they can be called all the names above because they are connected and have those properties. That's what I was saying about the square. Another example would be a rectangle. A rectangle will always be a parallelogram. A rectangle will always have 2 sets of parallel lines. But top down doesn't work. A parallelogram won't always be a rectangle. A parallelogram could be a rhombus. It could be a square. It won't always be named a rectangle. Okay, so that's how you read that one. This one's like a Venn diagram. The larger circle is quadrilaterals, and then it breaks it down into parallelograms, which means all parallelograms are quadrilaterals. Then it goes into rectangles, meaning all rectangles are parallelograms. And then it breaks it down even further to all squares are rectangles. Again, this inner circle is the most specific, which means a square can be called a rectangle, parallelogram, quadrilateral, but not so much from the outside in. All quadrilaterals won't always be squares. There's many different types of quadrilaterals. So again, it's that wording always, sometimes, or never where you have to watch that. Okay? And then this one again flows left to right. It talks about my general one is quadrilaterals, which can be parallelograms, which can be rectangles, which can be squares. So everything from left to right goes general to specific. And then if you look right to left, a square can be all three of these things. A rectangle can be these two things. A parallelogram can be this thing. Okay? So we're going to practice some always, sometimes, and never statements using these hierarchies. Again, the hierarchy kind of helps us understand if it works or not based on the location on the hierarchy. Remember, at the top, it's more general. It doesn't fit into a lot of categories, but if you're at the bottom, it gets more specific. You fit into more categories. So let's look here. It says all rectangles are parallelograms. We're trying to determine if it's true or false. So I look here. I first am going to find my rectangles because that's what I'm looking for, comparing it to. Rectangle are parallelograms. It looks like a rectangle is below a parallelogram. I remember if we're below what the thing on top is, it works. Another reason it works is because the definition of a parallelogram is two sets of parallel sides. A rectangle has two sets of parallel sides. So it can also be named a parallelogram. So I'm going to put a check mark here because that's true. Those parallel sides are, one set is there. Let me change the color for the other set. The other set is that top and bottom. Okay, let's look to that one. Number 2, all rhombuses are squares. So first I need to locate my rhombus, which is right here. All rhombuses are squares. So I look and the rhombus is on top compared to the square. That doesn't mean that's true. All rhombuses don't have to be squares because what makes a square is those 90-degree angles. And a rhombus doesn't always have those 90-degree angles. So that word all makes this untrue. Now, if I change that all to some, it could work. Some rhombuses will be squares, but it just depends on which one I'm talking about. So if you have a false statement, it'll normally ask you to correct it to make it true. So I just made that true with changing that all to some. So now it's right. Okay. So then we'll move on to the third one. All trapezoids are quadrilaterals. So I'm focused on trapezoids. Here's my trapezoids, and it's comparing it and thinking about the relationship to the quadrilateral. So can all trapezoids be quadrilateral? Well, trapezoid is underneath the quadrilateral. Quadrilateral is general, trapezoid specific. If it's on the bottom, it fits to everything that's connected to the top. And it is connected to the quadrilateral, which is on top. So that makes me think yes. If you are having a hard time reading the hierarchy like that, think about the definition. What makes a quadrilateral? A quadrilateral has 4 sides and 4 angles. Then you ask yourself, does a trapezoid have that? A trapezoid has 4 sides. Okay, a trapezoid has 4 angles. So it has to be a quadrilateral. Okay, so that one is true. So part of the hierarchy is just a tool to use to help you understand the properties and attributes of quadrilaterals. It also helps you understand different names that shapes and polygons can be called. But if you're having a hard time reading that hierarchy, that's why I created that geometry vocabulary slideshow. If you know the definition of these polygons and quadrilaterals, it really shouldn't be too bad, okay? Things can have more than one name, and that's mainly what this geometry unit's about. Think Miss Marshall. Miss Marshall, you guys call me Miss Marshall. TJ calls me Brittany or maybe Babe here and there when he's not mad at me. Arya calls me Mommy. My mom and dad call me Brit. They normally shorten Brittany for Brit. People at church, or if I'm out and about having to do documents, like I just got a new car, so I had to go sign some papers, they called me Mrs. Marshall. So depending on where I am, depends on my name. Same thing with geometry. Depending on the location it is on the hierarchy, depends on all the names you can be called. Depending on what makes me, my attributes, or what makes that polygon, the attributes, properties, depends on what name it can be called. So just remember that kind of thing when you're approaching your questions. Not everything has one name. There are many names to some things depending on those attributes and those properties. So I hope this is helpful. Make sure you're coming back to this video if you are unsure once you approach some of those hierarchy questions. I also encourage you guys to come to office hours Monday through Thursday from 1:45 to 2:45. I am going to be doing a small lesson at the very beginning of office hours this week, and then we'll jump into getting you help with your work. So y'all have a great week. I can't wait to see your submissions.